Hey guys, this is Ms. Hernandez. So this is our next video for adding, subtracting, multiplying, dividing fractions. This one will be about subtracting. So today we're going to do 4/7 minus 1/5. So if you remember from everything we've learned in class as well as the other video we watched, it's basically the same as adding the same process as if you were adding the fractions, but instead we're just subtracting. So we'll still be looking for our least common denominator and using that least common denominator to change our fractions and then do the math. So let's see what our least common denominator is. We'll be looking for the multiples of 7 and 5. Those are the denominators from our problem. So let's see, for 7 and 5, so we have 7, 14, 21, 28, and 35. So those are our multiples for 7, sorry. Next, we're going to look for the multiples of 5. So we have 5, 10, 15, 20, 25. Let's see, do we have anything in common just yet? Not yet, so we still have to keep looking. So let's keep going with our 5s. Next, we would have 30, 35, and then 40. Do we have anything in common now? Yes, we do. Between the multiples for 7 and 5, they both have 35. And that is the smallest number that's in common, the least common denominator. So that would be 35. I'm going to put it at the corner just so I remember. All right, next we have to change these fractions into fractions with a denominator of 35. So I'm going to go ahead and put down 35 as my denominator. Remember, we're still going to be subtracting, so I'm not putting adding, I'm subtracting. So we have to look at 4/7 and see how would we change that to something with the denominator of 35. So 7 times what gets me 35? Well, let's look at the multiples for 7 we did here on the side. We have, how many times did I count by 7? 1, 2, 3, 4, 5. We counted 5 times to get to 35. So 7 times 5 is 35. So I'm going to put times 5. Whatever I do to my denominator, I do to my numerator. So we're going to be doing 4 times 5 as well because we did 7 times 5. So what's 4 times 5? Hopefully you said 20 because it's 20. 5 times 4 or 4 times 5 is 20. Next, we have to change our other fraction, 1/5, to a fraction with 35 as its denominator. So how would I change 5 to 35? Let's see, how many times did I count up by 5 to get to 35? Let's see, 1, 2, 3, 4, 5, 6, 7. So we did 5 times 7 to get to 35. Whatever I do to my denominator, I also do to my numerator. So we'll also be doing 1 times 7. So what's 1 times 7? 7. Hopefully you got the same answer. Now all we have to do is subtract. Rewrite the fractions we just made. And we're still subtracting, remember that. And do the math. Whenever we are adding or subtracting fractions with the same denominator, that denominator does not change. So my denominator for my answer will be 35. Now all I have to do is 20 minus 7. So how about we do that on the side? 20 minus 7. Let's see, we can't subtract 7 from 0, so I'm going to borrow 1 from 2, so it'll change into 1, and this 0 will change into 10. Then 10 minus 7 is 3, and I put a 0 in my empty spaces, so 1 minus 0 is 1. So 13 over 35 is my answer, or my difference. Remember, difference is the answer for a subtraction problem. So if I were to tell you what is the difference from between 4/7 and 1/5, you would say it's 13 over 35 because that is the answer. How about we try another one? So our new problem is going to be 6/8 minus 2/3. So first off, like we do with the addition or just subtractions in general, we'll be looking for our least common denominator, or our LCD. So as we've been doing, we're going to find multiples for our denominators. So our denominators are 8 and 3. So the multiples for 8 are 8, 16, 24, 32, and 40. We're just going to go to 40. Now I have to find my multiples for 3. So hopefully you can go ahead and do this along with me. So we have 3, 6, 9, 12, 15, 18. Let's see, do we have anything in common so far? No, we have nothing in common yet. So let's keep going with our 3s. 18, 21, 24. How about we stop at 24? Do we have anything in common now between 8 and 3s? Yes, we do. We have 24. 24 here and 24 right here. And we don't have anything smaller than those two numbers that are in common. So our least common denominator is 24. Now we know that's going to be our new denominator. I'm going to put that down here already. And I'm still remembering that I'm subtracting. Now we have to change our fractions into the new fractions. So what I did is take 8 and multiply it by what to get to 24. Let's look back at our multiples and see how many times I counted by 8 to get to 24. We did 1, 2, 3. So 8 times 3 got me 24. Whatever I do to my denominator, I do to my numerator. So if I multiplied by 3, I multiply my numerator times 3. So 6 times 3 is what? 6 times 3 is 18. Hopefully you got the same answer. Then we change our other fraction to our new fraction. So let's see. 3 times what gets me 24? How about I look over here at my multiples and see how many times I counted by 3 to get to 24? We did 1, 2, 3, 4, 5, 6, 7, 8. So 3 times 8 got me 24. Whatever I do to my denominator, you do to your numerator. So multiply 2 times 8. What is 2 times 8? Or 8 times 2? 16. 16 over 24 is my answer for this one. All we have to do is rewrite our fractions and do our math. So 18 over 24 minus 16 over 24. Remember, our denominator will stay the same. It will not change. All you have to do is 18 minus 16. That's an 8. That's a 6. So 8 minus 6 is 2, and 1 minus 1 is 0. So 2 over 24 is our answer. Oh, wait. It looks like this answer might be able to be reduced. Now remember, guys, we're going over reducing fractions in class. So what's one thing that the numbers, the numerator and denominator for 2 over 24 might have in common? So now we're just looking at 2 over 24. We're trying to reduce it. So you might think that these numbers are both even. And that's true. 2 is an even number and 24 is an even number. So if they're both even, I could divide both by 2. When we're reducing a fraction, we have to divide our numerator and denominator by the same number. So if I'm dividing 2 by 2 on the top, I'm dividing 24 by 2 on the bottom. So what's 2 divided by 2? 1. 2 divided by 2 is 1. And what's 24 divided by 2? 12. So 24, 2 over 24 is equal to 1 over 12. 1/12 is the same as 2 over 24, except it's just reduced. Remember, if you were to have a problem, let's say on the STAR test, they're not going to give you a number like this one. They want you to give them the correct answer of the reduced one. So remember, you have to reduce if you're able to. It's always good to check if you can. One way you can check if you reduce correctly is to see if these two numbers are equivalent. And if we look to see if they're equivalent, all we have to do is our butterfly method. So we do 12 times 2, that would be 24, and 24 times 1, that would be 24. So if those two numbers are the same, we know that they are equivalent. So we did our math correctly. 2 over 24 reduces to 1/12. Alright, good job so far, guys. So let's try one more. So for this next problem, what I want you guys to do is look at the problem I gave you, and then pause the video and try to do this one on your own. After you finish doing this problem on your own, you can unpause the video, go through the process with me, and see if you did it correctly. So I'm going to go ahead and help start setting this up. And after I set it up, you can go ahead and pause it and then unpause, and you'll see me do the rest of this problem. So remember, you'll be looking for the least common denominator for 6 and 9, since those are the denominators we have in our problem. After you find what's in common, then you're going to change these fractions into the new fractions. Remember, try and see if you can reduce the fraction. You may or may not, but it's always good to check, just in case. Go ahead and try this one on your own. Alright, so if you decided to keep going, we're going to look at the multiples for 6. So we have 6, 12, 18, 24, and 30. Now look for the multiples of 9. So we have 9, 18, 27, 36, and 45. Let's see, do you see the least common denominator? What number do both multiples have in common? We have 18. 18 is the smallest number that's in common between the 6's and the 9. So I'm going to put 18 up here. Hopefully you got the same thing. Right. After that, we just have to change our fractions. So 6 times what gets me 18? We'll go ahead and set this up. 6 times 3 gets me 18. So whatever you do to your denominator, do to your numerator. So 5 times 3 is what? 15. So 15 over 18. Do the same thing with our 2 over 9. So how many times can 9 go into 18? Well, let's see. 1, 2. So 9 times 2 gets me 18. Whatever you do to denominator, do to your numerator. So what's 2 times 2? 4. Rewrite your fraction over here. So we have 15 over 18 minus 4 over 18. Remember, our denominator will stay the same. All we have to do is 15 minus 4. So 5 minus 4 is 1. 1 minus 0 is 1. So we have 1 over 18. Sorry, 11 over 18. Can this be reduced? 11 over 18? Well, actually, no, it can't. If you were to look at the multiples for 11 and 18, which is what we would do in class, multiples for 11 would be 1 times 11 and 11 times 1. Multiples for 18 would be 1 times 18, 2 times 9, 6 times 3, or 3 times 6, and so on and so on. You do not see anything in common between this column and this column, between these two. So that tells me this cannot be reduced. So the difference, or the answer for our problem, is 11 over 18. Alright guys, so for this problem, I want you to do this one completely on your own. Using what I showed you throughout this video, go ahead and solve this problem. And you can put your answer in the comment section down below, or you can send it through Seesaw, and I'll see if you got it right. So just remember, you can also try and reduce if you can, and see if that's the correct answer by using your butterfly method. So this is a problem I'm giving you to try on your own. 6 over 7 minus 1/3. Good luck, guys, and good job.